So let's get started. Let's talk about callbacks and higher order functions. Super. So is anyone, I know a lot of you are working through CSX, has anyone reached callbacks and higher order functions or worked through it? Okay, cool, some people. Okay, super duper. So callbacks, higher order functions, one of the most misunderstood concepts in JavaScript because it is. If you come from a different coding language, a different programming language, callbacks and higher order functions is not something that you can do. So I see people coming from different programming languages, they see callbacks, they see higher order functions, and they say, well, you can't do that. But in JavaScript, you can. So we'll talk a little bit about why that is. It also enables these functions like map, filter, reduce. Does anyone use these functions, map, filter, reduce, these array methods? A couple people. These are built on the concept of callbacks and higher order functions. So having an understanding of callbacks, higher order functions, this will allow you to kind of further understand how these array methods work under the hood. It makes our code more declarative, more readable. As we go through some examples, you'll see kind of why this is exactly. It also forms the backbone of the Codesmith technical interview. It is something that we do throw at you in the technical interview, but it's also a really foundational topic. A lot of the libraries, frameworks, technologies that we teach in the immersive program use callbacks and higher order functions. They kind of rely on these to allow specific functionality to work. So having an understanding of how this works will make it all the easier to understand these more complex technologies. All right, before we get into all of the good stuff, we are going to start off with some foundations. Now, this piece of code that is on the screen, you might look at this and say, like, I have written this like 500 times before. I know how this works, et cetera, et cetera. But we're going to spend quite a bit of time on this slide, dissecting every little piece, talking about what is actually going on. I'm a person that's all about fundamentals. I'm all about strong foundations. The stronger your foundation is, the stronger the code you build upon it will be. All right. So do I have a brave volunteer to go through this code with me, step by step? Dennis, you want to take us through? Sure. All right, cool. What is happening at the top of the screen? Declaring a variable to the value of 3. Cool. And what is that variable called? Num. Super duper. All right, awesome. So we're going to stop here. I told you we'd be spending a bit of time on this. All right, so in programming, you're really only ever doing one of two things. You are either creating data or you're doing something with that data. In this case, when we are declaring this variable num, we are creating data. And when we create data, we need somewhere to store that data. So we call this space the global memory. Global because we're kind of executing our code at the outermost level, which we call the global level. So we can set ourselves up over here with our global memory. So Dennis, do you want to tell me in your own words what is a variable?
It's a place where you store data.
Yeah.
Or it's a data type.
It's not necessarily a data type, but it is a place where you store data. All a variable is a label with some sort of data associated with it. So it's a human readable label. In this case, the label that we're working with is num. And the data that is associated with that is the value of 3. Cool. All right, super. Dennis, what are we doing next?
You're declaring a function called multiply by 2.
Okay.
The parameter of input number.
Okay, and where am I storing that?
You're storing that into your global memory.
Absolutely. So multiply by 2. And Dennis, do you know what we're going to store as its value?
Sorry?
Do you know what we're going to store as multiply by 2's value?
It's function definition.
Absolutely. Yeah, you're right. And when you say function definition, like what exactly are you referring to?
What I mean is that right now it's undefined, so it's not undefined. I'm sorry. It's going to take the whatever's happening in the function
Mhm.
because nothing's being returned yet. So it's just going to give you function multiplied by 2, const result equals input number, and such, all the way to return result.
Yeah, absolutely. When we talk about our function definition, this is everything basically inside of these curly braces. So, const result equals input number times 2, return result. All of that is our function definition that's going to be stored under the label of multiply by 2. And I could write all of that down here, but one, that would take a really long time. Two, it would be really messy and not very readable. So I'm not going to do that. Instead, I'm just going to use this little symbol that is a box with a little F and an arrow going through it. So if you see this little symbol here, this represents a function definition. Super duper. What are we doing next? Are we going into these curly braces? Are we going to execute this code right here?
No.
No. Why not?
Because it's not being called.
Because it's not being called. Yeah, absolutely. So when it comes to functions, functions have two phases. They have their definition phase or their declaration phase when we define them, and then they also have what's called their invocation phase when we call that function, when we tell JavaScript, hey, run all of the code inside of that function definition. Now, up here, when we were going through this, Dennis, you said we were declaring a function. How did you know that?
Well, because that's a really good question. I knew it because it says function, and it gives you the name, and then you have the parentheses. So with that parentheses, you would be putting in a parameter to be able to have something to call the function with. But that's
cool.
That's
No, absolutely. Absolutely. I would say, and tell me this is if you're not thinking this, I would say that this function keyword here is a pretty good, yeah, and you mentioned it. No, you absolutely mentioned it. But I would say that that's a pretty good indicator that we're declaring a function here. We can use this function keyword to tell JavaScript, hey, I'm defining a function. Cool. So what are we going to do next?
You're declaring a const named output.
Okay.
And it's equal to the function multiply by 2 with the parameter of num.
With is it a parameter of num?
Sorry, it's an argument.
Cool. All right, and where are we storing this variable output?
You're storing the variable into your global.
Super duper. All right, cool. So we're declaring this variable output. And right now, Dennis, do we know what the value of output is going to be at this very moment?
Yes.
Do we? Let me rephrase that. Does our computer know what it's going to be?
No.
No. Absolutely. We might know, if we multiply the number 3 by 2, we all know that that is going to be the number 6. But our computer doesn't know that. Our computers are smart, but they're only as smart as we program them to be, which I think is pretty cool. Cool. So we've declared this variable output, and we are setting it to be what we call the evaluated result of invoking multiply by 2 and passing in num, as Dennis said, as an argument. Now, Dennis, how did you know that we were invoking multiply by 2?
The parentheses.
Cool. Yeah, absolutely. Whenever we invoke a function, we can just write its label name, in this case, multiply by 2, and then use those parentheses to tell JavaScript to run the code inside of that function definition. All right, cool. So like we said, we're not sure what output is going to be just yet, but we could figure that out. So right now, this is the code we're executing. We have output is going to be the evaluated result of calling multiply by 2, passing in num. And Dennis, what is the value of num?
3.
Absolutely. It's going to be 3. Cool. So whatever this evaluates to will get stored in that variable output. Now, y'all, we have invoked a function in JavaScript. What do we need? Not necessarily. We'll get to that. But if you... Yes, absolutely. A local execution context. Yes, super duper. All right, cool. So basically, we need an execution context specifically for this function call. So we'll call this a local execution context. We'll make it, that's big enough. Okay, cool. And inside of this local execution context, we'll also give this a local memory. All right, super duper. We invoke the function. We have our execution context set up. Dennis, what is the first thing that we need to do?
In the local?
Yes.
You would put in
This.
oh, you're pairing the parameter with argument.
Yeah, absolutely, 100%. Before we can do anything, we need to pair our arguments with our parameters. What is our parameter in this case?
It is input number.
Absolutely. So we've got input number, and where are we storing this?
You're storing it in the local memory.
Absolutely. Cool, cool. So we have input number as the parameter. And what is the argument?
It is 3.
Absolutely.
Which is equal to 3.
Absolutely, it's going to be 3. Super duper. Okay, now what do we do?
You're multiplying it by 2.
Multiplying it by 2, but a little bit more technically. What are we doing on this line of code?
You're declaring the result.
Declaring the result. And what is result?
It's equal to input number, the parameter input number to the times 2.
Cool. But result is going to be, what do we call this in JavaScript? What is the technical keyword for what result is?
It's a variable.
Absolutely. Yeah, we're declaring a variable with the label result. And where are we storing that?
In the local memory.
Absolutely. And what is going to be the value of result?
Result is going to be input number times 2.
Absolutely, which is?
It's a 6.
Super duper. All right, cool. And then what do we do?
You're going to store, you already did that, never mind. You're going to return the value of result.
Super duper. So we are returning this value out into global memory. And where is this value going to live? Where is that going to be stored?
It's going to be put into the global memory of output.
Absolutely, 100%. Cool, cool, cool. All right, super duper. Now what do we do? What is the next thing that we're going to run?
It's going to declare the constant new output.
Cool.
Which
And
is equal to multiplied by 2 with the argument of 10.
cool. And where are we storing this variable new output?
You're storing that in your global memory.
Super duper. All right. So we're saying new output will have the value of invoking multiply by 2, passing in 10. Do we know the value of this just yet?
Yes.
We do?
No, you don't.
Absolutely not. Why not?
Because right now, well, no, yeah, I would guess you do. Is 10 is inside the parameter of that function, which would be multiplied by 2, which would equal to 20.
But have we run that functionality yet? Has our computer run that functionality? No?
No.
So do we know the value?
No.
Absolutely not. No, our computer has not run that functionality yet. So new output for the moment is undefined. Okay, so now we're saying new output is going to be the evaluated result of invoking multiply by 2, passing in 10. Okay, cool. So whatever this evaluates to will be stored under here. All right, so we invoked another function. What do we need?
Yeah, local execution.
Super duper. We need our local execution context down here. All right. Now, Dennis, we've got our local execution context set up with our local memory. What is the first thing we need to do?
You're going to declare.
Before we declare anything, what was the first thing that we did up here?
Oh, you paired the parameter with the argument.
Super duper. Awesome. And what's the parameter?
It's input number.
Absolutely.
And it equals 10.
Super. Yeah. So we have input number, and that argument is 10. All right, cool. So now what do we do?
You declare the constant results
Mm-hmm.
equal to the input number multiplied by 2.
And
It would be 10
cool.
times 2
And where are we storing result?
in
Awesome. So we're storing result in the local memory. And as you said, this is going to be input number, which is 10 times 2. So result is going to be?
20.
Absolutely. And then what do we do?
You're going to return the value of result
Mm-hmm.
and store it into the new output in the global memory.
Super duper. Awesome, awesome. All right. Cool, cool, cool. Awesome. Thank you, Dennis, for going through that with me. Awesome. Awesome job. Yeah. So cool. We were able to declare this function multiply by 2, and we were able to invoke it 2 times. We were able to run that functionality inside of there 2 times with 2 different values. And this is one of the great things about functions. They are reusable pieces of data. So now anytime I want to multiply a number by 2, all I have to do is invoke that function instead of writing that code inside of the function over and over again to multiply a number by 2. So this is fantastic. Now, a couple other things that I want to talk about before we move on from this slide. So JavaScript is what we call a single-threaded language, meaning that it can only do one thing at a time. There's some languages that are multi-threaded, so they can do multiple things at a time. Imagine that. But basically, JavaScript is single-threaded. So it has this thing called the thread of execution. Has anyone heard of the thread of execution before? Super duper. Cool, cool, cool. So there's this thing called the thread of execution. I abbreviate it to the toe, and some people don't like that, but I think it's fine. So if you want to say that around me, I'm not offended by it. But basically, there's this thread of execution, and what it does is it reads through our code from top to bottom, left to right, kind of like how you would read a book, and it executes our code. So the way this works is that the thread of execution starts out in the global execution context, and it starts working its way through our code. So it sees at the top here, we are declaring this variable num, assigning it the value of 3. We're declaring multiply by 2. Cool, cool, cool. We declare output. And then it sees that we invoke multiply by 2. And we're passing in num. And this is when we open up this local execution context over here. So what the thread of execution does is it stops running in the global execution context. And what it does is it threads its way into the local execution context of multiply by 2. And then it will start executing code inside of there. So it'll see we're declaring this variable result, and then it'll see that we are returning result. Now, as soon as this thread sees this return statement, that kind of tells the thread of execution, hey, we're done inside of this function. We're done running code inside of here. So the thread of execution, again, will stop running inside of this local execution context, and it'll thread its way back out into the global execution context, where it will continue to run. It'll see that we're declaring this variable new output, and then it'll see, again, we are invoking multiply by 2 one more time. So it'll stop again, thread its way back into here, execute the code inside of here. As soon as we hit that return keyword again, it'll stop and thread its way back out. So that's kind of how the thread of execution works. Now, we're not really going to diagram the thread of execution today. It's just something that I want you all to be aware of, so don't worry about it. But basically, JavaScript needs a way to keep track of the thread of execution, as well as all of the execution context that it has open at any given time. So it uses this very common data structure to keep track of this. And I'll put this over here. It uses this thing called a stack. Has anyone heard of a stack before? OK, cool. A couple of people have. Basically, this is just a data structure that focuses on what we call the last in, first out principle, or LIFO. But basically, it uses this stack to keep track of all of its execution context. Whatever is at the top of the stack is where we are currently running our code. So what is at the base of the stack is always going to be the global call, so the call to the global execution context. So whatever is at the top of the stack, like I said, is wherever we are running code at the moment. Now, whenever we invoke multiply by 2, passing in 3, and we open up this local execution context, we are going to add a frame to the stack representing this execution context. So we have multiply by 2, passing in num. And now, multiply by 2, passing in num is at the top of the stack. So this is how JavaScript knows this is where we're executing code right now. Whenever we hit this return keyword and our thread leaves this execution context, we'll remove multiply by 2 from the stack, and we'll see again that the global call is at the top of the stack again. So this is how JavaScript knows where it has to go back to after it's done running code in a specific execution context. So this stack basically focuses on keeping track of all of our function calls. Does anyone know what this is called? That's okay. Yes, absolutely. This is called the call stack. Yes, because like I said, it keeps track of all of our function calls, essentially. Super duper. So, Greg, do you know what it's called? Do you know what it's called whenever we add a frame to the stack? What is the term we use to describe that?
I forget. And I was just in the class last week.
No worries, no worries. Dennis, do you know?
It's pushing.
Yeah, absolutely. We push onto the call stack. Greg, do you know what it's called when we remove something? Knowing that add? Yes, absolutely. Popping, yes. Think of like the array methods push and pop. Absolutely, 100%. So we'll be talking about the call stack today. So we'll be talking, whenever we open up an execution context, we'll say that we are pushing a stack frame onto the call stack. And whenever we leave that execution context, we'll be talking about how we're popping that stack frame off of the call stack. And this will help us all keep track of, where we are executing code. So the call stack is something we're going to go through today. This is something that also gets really important when you start talking about like recursion and stuff like that. Your call stack is really important so you can keep track of where you are. Cool. Now, the last thing I want to talk about is what happens whenever we leave an execution context. So whenever we are done running code inside of an execution context and our thread leaves that execution context, we pop that stack frame off of the stack. All of the data, all of the functionality that was run inside of this execution context is going to be kind of wiped away. It's going to be deallocated from memory. And this is what we call garbage collection in JavaScript. And that is the real term for it. So JavaScript is an automatically garbage collected language. This happens automatically without us having to write functionality for it. So every time that we leave this execution context, everything that happened inside of here will be gone. And the only thing that remains is this value of 6. And that's because we returned that value from this function and we stored it in this variable output over here. So we'll be talking about this a bit today. Now, garbage collection, it's going to become super important when you talk about concepts like closure and even recursion. But for today, just something good to keep in mind that it happens. So whenever we leave an execution context, we pop that frame off the call stack. We'll also be talking about garbage collection. OK, super duper. Any questions so far? Cool, cool. All right, y'all, let's get this off of the board. Super. OK, cool. Now we can move on. All right, so let's start getting into the fun stuff. OK, why do we even have functions? OK, so what I want to talk about right now, I want us to create a function called 10 squared. This function will take no input, and it's going to return 10 times 10. What is the exact syntax that you would write if you wanted to create this function? Let's see. Who wants to give it a go? Greg? What would I write on the board?
You'll write function function.
Okay.
Squared equals, I would say 10 squared.
10 squared, okay. All right, cool. So we have our function 10 squared, okay. It takes no input, so what would I write next?
Curly brackets.
Curly brackets? I would write curly brackets, but I'm missing one thing right here.
Equals.
Equals?
Oh, it takes no, parentheses.
Absolutely, parentheses. Yeah, and am I putting anything in here?
No, because it says takes.
Absolutely, yeah, no, because it takes no input. What am I writing in the function definition?
I guess you write return.
Okay. 10 times 10. Cool. I think that this looks pretty good, right? Cool. Absolutely. Function 10 squared takes no input, and this returns 10 times 10. Awesome. Fantastic. 100%. Yes, you were. Yes, absolutely. You were right. Don't doubt yourself. No, that's great. Yeah, super. So cool. Now we have this function 10 squared, and I can invoke it, and it will return to me 100, 10 squared, right? And I can invoke this function 100 times, and each time it is going to return to me the value of 100. And this is great. This is fantastic. So every time that I want to square 10, I can just invoke 10 squared, and it will return to me 10 squared. And I love that. And I love that so much that I did this, and I created an application that does this. So I created this application, and I called it 10 squared. And people could go to this application's website, and I would show them what 10 squared was. And people loved that. They thought it was really inventive. They thought it was really useful, and I did too. And people loved this so much that I anticipated the needs of my users, because that's what you have to do. So I created a function called 9 squared, and I added it to my application. Does anyone want to guess how I created 9 squared? The same way? Yeah, the same way. Yeah, and I called this function 9 squared. Yes, and it returns 9 times 9. Now, my users can go to my application, and they can choose to either see 10 squared or 9 squared. And this blew up, and people loved it. And they were like, everyone was talking about it, you know, like, have you heard of this application where you could square 10 and 9? It was pretty cool. I was, you know, a lot of fame. I was feeling very successful. So I did what I do best, which is anticipate the needs of my users. And you guessed it, I created 8 squared. Yes, I created 8 squared, and people went wild. Now they could choose to square 10 or 9 or 8. And this was a huge success of mine. It was incredible. I was just feeling so great. And then something horrible happened. Someone stole my idea for this application, and they created square num, and it was awful. It kind of rendered my application useless. With this function, square num, people could go to this application, and they could square any number that they wanted to with one function. One function. I had 3 functions. I had 10 squared, 9 squared, and 8 squared, and I could only square 3 numbers, but this person allowed people to square whatever number that they wanted. And it was really awful, and it was really sad for me, but I learned, you know, you can just never see these things coming, so you just have to be ready for that. But I also learned a couple more things from this. I learned that I was being really repetitive with my functions that I was writing. Now, I wasn't directly repeating the exact code. You know, 9 squared is a different word than 10 squared and 8 squared. But ultimately, I was repeating the same functionality over and over again, right? Has anyone heard of the dry principle? Yes. Sharif, what does dry stand for? Yeah, absolutely. Don't repeat yourself. And I was repeating myself over and over again. I also learned that I can generalize my functions. We get these things in JavaScript called parameters, which are basically placeholders, so that you don't have to define the exact data that you're going to work with inside of a function. And then we can pass in a value called an argument to take the value of that parameter when we call the function. So this is something really great about functions. They are kind of these bits of general repeatable code that we can use. Cool. Can I get thumbs on this concept of like parameters, arguments? Thumbs up if you're feeling good, thumbs in the middle if you're like, I don't really know, thumbs down if you're like, I don't know what's going on at all. How are we feeling? Let's take a look at this. All right, so we have up here a function, copy array and multiply by 2. And this function does pretty much exactly what it says it does. It copies an array and multiplies every element in it by 2. So we're going to diagram through this. I'll get us set up. Let's do our global memory over here. I'll give us a call stack over here. And we'll put our global execution context right here. All right, cool. Does anyone want to go through this with me? Yeah. Sorry, you're Taylor.
Yeah.
Oh, yes. OK, cool. I'm not going to have to ask by the end of this, I promise. OK, Taylor, do you want to walk through this with me?
Sure.
Super duper. Start us off at the top.
Yeah, so we will declare a function
Mhm.
with the label copy array and multiply by 2,
Super.
which we'll place in global memory.
Super duper.
And for now, we'll set it equal to, or set it, we'll assign it to the function definition.
Super duper. All right, cool. So we got copy array and multiply by 2. And we're storing inside of it a function definition. Super duper. What are we doing next?
Next, we'll declare a constant to label myArray.
OK.
And assign it to an array with elements 1, 2, and 3.
Cool. And where are we storing that?
In global memory.
Super duper. So we've got my array. All right, super duper. And then what are we going to do next?
Then we will declare a constant to label result in global memory.
Super.
And we will assign it the evaluated result of the invocation of copy array and multiply by 2, passing in the argument myArray.
Super. So do we know what result is going to be right now?
No.
No, absolutely not. Cool, cool, cool. So we'll just put kind of an underscore right here. All right, cool. So we are running this code. We're saying result will be the evaluated result of copy array and multiply by 2. Y'all, this is a lesson. When you're naming your functions, please don't name them something like this. It is so long. Copy array and multiply by 2. And we're passing in my array. Super duper. All right. Taylor, we are invoking this function. What do we got to do?
Because we are invoking it, in parentheses, we're going to open up a local execution context.
Super duper. Let's make this one really big. All right, one more thing we got to do. Has to do with this.
Oh, and then we have to push copy array and multiply by 2 onto the call stack.
Super. Absolutely. And y'all, I'm not going to write out copy array and multiply by 2. I'm going to abbreviate it to copy array and multiply by 2. We just don't have enough time. No, we wouldn't be able to read it. OK, cool, cool, cool. All right. Super duper. So we've got our call stack set up. We've got our local execution context set up. What is the first thing that we have to do?
First thing we want to do is pair our parameters with our arguments.
Super duper. What is our parameter?
Our parameter is array.
Absolutely.
So on local memory.
Okay.
We will assign it the argument myArray.
Cool. And what is the value of my array?
Well, we don't know yet, right?
My array.
Oh, okay, sorry.
No, don't apologize.
The array 1, 2, 3.
Absolutely, yeah. So JavaScript is going to see, oh, my array, I know where I can look for that. It'll look in global memory, see this label, and the value of 1, 2, 3. Super duper. So we got 1, 2, and 3. Okay, cool, cool, cool. Now what do we do next?
Okay. Now we're going to enter the function code block.
Mhm.
And so we'll declare in local memory
Mhm.
a constant with the label output.
Okay.
And assign it an empty array.
Super duper. Okay. And then what do we do next?
Then we're going to enter a for loop.
Okay. Cool, cool, cool. So I'm going to stop us right here. How do we feel with for loops? Can I get thumbs on for loops? Thumbs up if we're like, cool. Thumbs in the middle if you're like, I don't know. Everyone's feeling good about this. Okay, super. That makes my job a lot easier. For loops are kind of wonky to diagram, but we're going to go through it together. We're going to do it a couple times. It's going to be great. But let's talk about what is going on up here. We have these 3 statements inside of here. Taylor, can you tell me what is this first statement doing?
The first statement is declaring a let variable I, or initializing I, with the value is 0.
Cool.
It's kind of a starting place to essentially like run through an array.
Yeah, absolutely. I like the term starting place that you used. This is what we kind of call our initial value. Whenever we set up a for loop, we need 3 things. The first one is our initial value, and this is just some value that is a starting place, something that we're going to work with. Absolutely. Whenever we declare this variable I, Taylor, where are we storing that?
That'll be stored in local memory.
Absolutely, yeah. So we could just store I over here, initialize to the value of 0. Now, what is this condition in the middle? What is this statement?
So the conditional is as long as I is evaluating to be less than the length of the array, and the length of the array is like the number of elements in the array. So with it being 0, it's less than 3, which is the length of the array.
And what does this tell our computer, per se? What does this mean for our computer?
It's essentially like evaluating to, I guess, like truthy.
Mm-hmm.
So you would proceed. You're not exiting the for loop because your conditional says, proceed, like enter the code block.
Yeah, absolutely. The second statement is called our breaking condition. So this is really important for looping, but whenever we are performing some repetitive action, i.e. whenever we're looping, we need a way to tell our computer to stop doing that thing. Like I said before, our computers are smart, but we have to tell them what to do. So here we're saying as long as I is less than the length of our array, keep performing this repetitive action. Keep running the code that is inside of this for loops code block. But whenever that statement evaluates to false, whenever I is no longer less than the array length, that tells our computer to stop performing that repetitive action. It tells your computer, hey, stop doing all of this, let's exit out of the for loop. Fantastic. And Taylor, what does this last statement do?
That's an incrementer. We wouldn't handle it just yet right now, but once we go through the code block, then we would increment I, and plus plus is shorthand for raise it 1.
Yeah, absolutely. Perfect. So this is our update condition. Essentially, the update condition is what we run after we've run the code inside of our loop. But the update condition, the whole purpose of this is to bring us closer to that breaking condition so that we can eventually break out of that loop. Okay, Cool. How are we feeling? Thumbs, thumbs, thumbs. Okay, super. Yeah, do you have a question?
I kind of had a question.
Okay.
How come if it's less than the length of the array, why doesn't it stop before you've completed the array? Because shouldn't it be like less than or equal to the length of the array?
So you can set up this condition however you would like. But as you're going through this, I would definitely recommend trying out both approaches and seeing what happens. There are some conditions where you might want your breaking condition to be I is less than or equal to array.length. But in this situation, we'll kind of see as we diagram through it why this is the case. But yeah, if you still have this question after we diagram through everything, we can talk about it again. Does that sound good?
Yeah.
Okay, super duper. So we've set up our for loop. We have I in our local memory. And we know we need to check if I is less than our array.length. So on our first iteration, is I, Taylor, less than our array length, which you said was 3?
It is not, so we're going to enter the block.
It is not?
Wait, 0 is definitely less than 3, sorry.
No, don't apologize. You're fine. Yes, absolutely. Cool, cool, cool. So we're free to enter that block. All right, super. What are we going to do?
Okay. So entering that block, we're going to look at evaluate I at the zeroth the word.
Yeah, you can say that.
Index,
Okay.
which is the first element in the array, which is 1.
Yeah. Super duper. Yeah, so we're saying array at the index of 0, and arrays are 0 index based. So that 0th index is 1 times 2. Super duper. So where do we add this?
It'll be the first element and output.
Absolutely, 100%. Cool, cool, cool. All right, now what do we do?
Then from there we would increment I.
Uh-huh.
By 1. So now I will be 1.
Okay.
And we will evaluate the breaking condition. 1 is less than array.length, which is 3.
Mm-hmm.
So we will enter the code block.
Cool.
And array at the first index, index 1, is
Uh-huh.
2.
Super.
So we'll multiply that by 2
Okay.
equals 4,
Uh-huh.
which will become the second element in the output array.
Super. Okay. Then what do we do?
Then we'll increment I again. So I will now equal to evaluate the 2. And 2 is less than 3, our breaking condition. So we'll enter code block and array at index 2 equals 3. And we'll multiply that by 2. And our third element of the output array is now 6.
Super duper. Okay. Whoops. I have too many markers. Okay. Cool, cool. And then what do we do?
Then we'll increment I to 3.
Okay.
And the breaking condition occurs. 3 is not less than 3.
Mm-hmm.
So we will exit our for loop.
Uh-huh.
And we will go down to return the
Uh-huh.
output array, which we will be exiting this local execution context and returning that into the result
Absolutely.
in global memory.
Super. Absolutely. So we're storing this array with the values 2, 4, and 6 in global memory. Okay. Super. Now,
Oh, and we got to pop that call stack.
we...
That stack frame.
Yes, absolutely. I saw where you were going. Yes, absolutely. We're popping that frame off of the call stack. And one more thing that we've got to do.
We've got to garbage collect our local execution.
Absolutely. So everything inside of here will be wiped from memory except for the array with the numbers 2, 4, and 6 because we stored them over here in result. Cool. That was pretty cool. We were able to do whatever the function told us to do. Taylor, thank you for going through that with me. That was awesome. So super. Now, the good thing about this is that our function is pretty generalized, right? We used this parameter of array so that we didn't have to know exactly what array we were going to work with when we wanted to copy it and multiply it by 2. Now our users can pass in any array that they would like to this function, and it will copy every element in it and multiply it by 2. They could pass an array with 100 numbers in it or with 5 numbers in it. It doesn't matter. We're kind of leaving that up to them. We're giving them that freedom, which is great. I would say that this is a pretty practical function. I don't know. I might use this in an application somewhere. Cool. So any questions on this? Any questions about what we went over? Cool, cool, cool. All right, super. So if you all liked this, I want to talk about this other function, copy array and divide by 2. Now I'll let you all kind of let that sink in, but kind of like what we just saw, this function does exactly what it says it does. It copies an array and it divides it, every element in it, by 2. And again, it's pretty general. We're allowing our users to pass in whatever array they would like to this function. So let me get rid of all of this. Do I have anyone who would like to diagram through this with me? Anyone who wants to walk through this with me? Sharif? Yeah. OK, super duper. Start us off at the top.
Line 1, you're declaring a function.
Uh-huh.
The label copy array and divide by 2.
Super duper. Copy array. Oh, yeah, I'm going to write it out. Copy array and divide by 2. Cool. And what are we storing as its value? Absolutely, a function definition. Cool, cool, cool. What are we doing next?
I'm going to go down to declaring a constant, my array.
Super duper. And where are we storing that?
In local memory.
Awesome.
Its value is an array of 1, 2, 3.
The value of 1, 2, 3. Absolutely. All right, what are we doing next?
Now I'm going the line below that.
Mm-hmm.
And you're declaring a variable, a constant variable result.
Uh-huh.
And you're assigning it the evaluated result of invoking copy array and divide by 2 function,
Uh-huh.
passing in my array.
Cool, cool, cool. So do we know right now what result is going to be?
No.
No, absolutely. OK, stunning. So right now, we are going to be running this line of code. Result equals the evaluated result of calling copy array and divide by 2. I bet the suspense is just killing you all. What's going to happen? All right, cool. And we are passing in my array. Absolutely. OK, super duper. So whatever this evaluates to will be stored under result. All right, Sharif, what do I have to do next?
Well, we're invoking a function, so we have to open up a local execution context.
Absolutely. We're opening up a local execution context. And one more thing that we got to do.
We're going to create a local memory.
Absolutely.
We're going to also push that step into the callback.
Absolutely. Memory. Super. OK, we have copy array and divide by 2. Super duper. All right, now what do we do?
You're going to create those memories and arguments.
Super. And what is the parameter?
Parameter is array.
Absolutely. The parameter is array. And what is the argument?
Argument is my array.
Cool.
So its array's value
Uh-huh.
is going to be 1, 2, 3.
Absolutely. 1, 2, and 3. Fantastic. Now what do we do?
We are now inside the body.
Uh-huh.
So we're going to be declaring a constant
Mhm.
variable called output
Super. And where are we storing that?
in local memory.
Absolutely.
And its value is
Perfect. Okie dokie. What do we do next?
We are now going to go a line below,
Uh-huh.
and we're going to be initializing a order.
Okay, super duper.
So we are now going to be declaring
Uh-huh.
a I
Uh-huh.
and setting its value to 0.
Absolutely. And where are we storing that?
And look,
Fantastic, 100%. All right, cool, cool, cool. And what is our breaking condition that we'll be checking?
checking if I
Uh-huh.
less than
Uh-huh.
the array by level.
Super duper. All right, cool, cool, cool. All right. Ready?
I believe so.
Okay, cool. Let's go.
So with that check,
Uh-huh.
and that I is 0,
Uh-huh.
we're checking if 0 is less than
Uh-huh.
the array length.
Uh.
The length should be 3.
Uh-huh.
So that check's okay.
Okay.
So we're now allowed to go inside that body.
Uh-huh.
So once we get inside, we are now calling the push method
Uh-huh.
of that array. And we are passing in the array
Mhm.
index 0
Okay.
divided by 2.
Cool. And what is array at the index of 0?
It is 1.
Absolutely. So we've got 1 divided by 2, which is,
1.5. Well, half.
yes, super duper. We'll put 0.5. Cool, cool, cool. Okay, what do we do next?
We now have to increment our I.
Uh-huh.
So once we increment, I is now going to be 1.
Okay.
We now check our conditional.
Uh-huh.
So that's 1 is less than array dot length.
Uh-huh.
Passes. So we go back into the body,
Okay.
and we're now doing output push,
Uh-huh.
and we are going to be using the index of 1,
Uh-huh.
which that is going to evaluate to 2.
Super. Okay.
So it's 2 divided by 3, which is 2/3.
2 divided by,
Sorry, no, that's 1.
you got it. Yeah, 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 absolutely. 2 divided by 2,
Divided by 2, yes.
which is 1. I've got way too many markers. Okie dokie. And then what do we do next?
We are now going to increment again.
Uh-huh.
So I is now going to be 2.
Uh-huh.
We now check that condition.
Uh-huh.
2 is less than 3, so we now go inside the body.
Okay.
We are now going to do output push once again.
Okay.
And array at index 2
Uh-huh.
is going to be 3.
Super.
So 3 divided by 2,
Uh-huh.
which is 3 over 2.
Mm-hmm.
And that's going to be pushed into the output array.
Super duper. So I'm going to put 1.5. Super duper. All right, what do we do next?
We're now going to increment again.
Uh-huh.
Making our I evaluate to a 3.
Uh-huh.
So we want to do that condition check.
Uh-huh.
Is less than 3, that is false.
Yeah.
So we no longer insert the body and we move on to the final line,
Uh-huh.
which is going to be returning that array.
Awesome. Awesome. And where are we storing that?
That is going to be open array, and that's going to be stored in the constant variable low memory of result.
Awesome. Yeah, it's going to be stored under result. A couple things we need to do to clean up.
We are going to garbage collect,
Uh-huh.
and we're going to pop the stack frame off the call stack.
Super. Absolutely. We're going to garbage collect this. All of that is going to be gone. And we're popping the stack frame off of the call stack so we can return to global memory. Fantastic. Absolutely. Thank you, Sharif. That was excellent technical communication. All right. Super. So we were able to copy an array and divide every element by 2. Super exciting. Now, if you liked this and you liked copy array and multiply by 2, you're never going to guess what I have for you next. Yes, we have copy array and add 3. Woohoo! So fun, right? We're not going to go through this, don't worry. Yeah, so cool that we can now copy an array and add 3 to every element. But what's happening here? What's the problem that is starting to form here? Specifically, what principle are we breaking? Yeah, the dry principle. Don't repeat yourself. I mean, let's compare. Let's look at copy array and add 3. Let's look at copy array and divide by 2, and copy array and multiply by 2. What is changing about all of these functions in the function definition? Patrick, do you know what's changed? What is changing?
Well, I mean, okay, I was going to answer that, but then I was just like thinking in my head. I was just saying that it would be easier, obviously, if we just had a second argument to put what function we wanted to apply to the array.
Yeah.
To change the value.
Absolutely. That was going to be my next question. How do we solve this? Yeah, absolutely. I mean, let's be real. Let's look at this. The only thing changing from all of these functions is, first off, the name. It's still ridiculously long, but we're just changing the functionality of the name, copy array and multiply, copy array and divide, et cetera, et cetera. And we're just changing these 2 characters right here. Multiply by 2, divide by 2, add 3. So we are repeating the same code over and over and over again. Now, we are definitely making steps in the right direction here, right? We've generalized this function by allowing our users to pass in any array that they would like to. So, when we define this function, we don't have to know the exact data that we are going to work with, but we can do better. As Patrick said, we could add a second parameter to allow users to pass in the functionality that they want to run. So in other terms, we could generalize our functions even more. So at this point, our users don't, when we define this function, we don't have to know the exact data that we want to work with, but we also don't have to necessarily know all of the functionality that we want to run at the time that we define this. So, cool. Does anyone want to go through this with me? Dennis, you want to give it a try? Cool. All right, start us off at the top.
You're declaring a function, copy, array, and manipulate.
Okay, cool. And where am I storing that?
In the global memory.
Super. Copy, array, and all right, cool. And what are we storing as the value of this?
You have the parameters, array, and instructions.
Okay, but more so, what am I going to store over here?
You're storing a function definition.
Super, absolutely. So everything inside of those curly braces over here, storing inside of here. Okay, cool. What do we do next?
So you are declaring const named output, and it's equal to an empty array.
So have we invoked copy array and manipulate?
No.
So we're going inside of here?
No.
Okay.
No.
No worries. Don't apologize. It's okay.
So now we're skipping that, and we're declaring a function multiplied by 2
Super duper. And where are we storing that?
in the global memory.
Absolutely. And what are we storing as its value?
Function definition.
Yeah, absolutely. And I'm just going to change the color of this just so we can kind of tell the difference when we go through this diagram. So I'll make this function definition blue. Okay, cool. What do we do next?
You are declaring a const named results,
Uh-huh.
and it is equal to copy, array, and manipulate with the arguments array
Uh-huh.
and the function multiplied by 2,
Cool. And
which is the instructor.
yeah. And do we know the value of result right now?
We do not.
Absolutely no. We do not know this yet. Okay, cool. So we are invoking.
A local execution.
Absolutely. So we will copy array. Manipulate. All right, cool. And like you said, we're passing in an array with the values 1, 2, 3. And we're passing in the function definition of multiply by 2. Super. All right, and like you said, we need to open up a local execution context. And then one more thing that we need to do. It has to do with this.
Yeah, we're creating a call stack.
Creating a call stack?
We're creating a local memory.
We are creating a local memory, but what do we have to do to our call stack?
We're pushing in the function copy array manipulate.
Yeah, absolutely. We're pushing a frame to the call stack for copy, array, and manipulate. All right, super duper. So we've got our local execution context set up. What is the first thing we have to do?
We're pairing in the parameter array.
Cool.
With the argument.
Uh-huh. And what is the argument?
It is bracket 1, 2, and 3.
Bracket 1, 2, 3. And what kind of data type is this?
That's an array.
Absolutely. So it's going to be the array with the elements 1, 2, and 3. And then what is our second parameter?
It is multiplied by 2.
Is it multiplied?
Function multiplied by 2.
Is multiply by 2 the parameter or the argument?
Argument.
It's an argument, yeah.
So we're
absolutely.
pairing the parameter with the argument multiplied by 2.
And what is the parameter?
It is a function definition.
It's the parameter is a function definition?
Sorry, it's multiplied by the instruction.
Yeah, absolutely. So the parameter is what's going to be the placeholder defined in our function definition. In this case, our parameter is instructions. Instructions, and like you said, the argument is the function definition for multiply by 2, which we defined out here in the global memory. So cool. So now we kind of have this function definition, but it's stored under a different label now. So it's stored under instructions. Cool. What do we do next?
So now we declare a constant named output
Okay. And where do we store that?
into the local memory.
Okay. Cool. And what is the value of output going to be?
It's an empty array.
Super duper. Awesome. And then what do we do?
We are creating a for loop
Absolutely.
with the starting point of let I equals 0
Okay. So where are we storing this?
in the local execution.
In the local execution or the local memory?
The local memory.
Super. So we've got our variable I with the value of 0. Okay, cool. Now what do we do? We know, sorry, go ahead.
We are creating the condition of the break, which is as long as I stays less than the array length, or the array length.
Okay.
And we're incrementing it plus 1.
Are we incrementing it right now?
No.
Okay. So what are we doing right now?
I'm sorry, I'm not sure.
Not sure. Okay, who can help him out? Yeah.
You are going to invoke the function that you call with the second parameter, instructions?
So not just yet. We have to do one thing to tell our computer, hey, it's okay to run the functionality inside of this for loop. What is it? Sharif, I see you shaking your head.
You have to check the condition.
Absolutely. And what is a condition?
It's I is less than the array length.
Exactly. And is it? Absolutely. Okay, cool. So first we have to check our condition. This tells our computer, hey, it's good for you to run the code inside of this for loop. All right, Dennis, what are we doing now? We're right here.
Okay. Yeah, you're getting the. I'm sorry, I don't know. I'm blanking out right now.
That's okay.
Odd reason.
No worries, no worries. Does anyone want to help him out?
No.
Yeah, cool. Sharif, what are we going to do?
So once you get into that body,
Mm-hmm.
you are going to basically locate the array output
Mm-hmm.
and you put the right there.
Okay. Uh-huh.
passing in array
Uh-huh.
index 0
Okay, which is
is 1.
cool, cool, cool. All right. So we invoked a function. So what do we got to do?
Open up another local execution.
Absolutely. And I'm going to make this kind of small, but it'll be big enough for what we need to do. All right, cool. So we'll give ourselves a little local memory over here. And then one more thing that we need to do since we invoked a function.
You mean local memory? Or, oh, I'm sorry.
No, don't apologize.
You have to push that stack frame onto the call stack.
Absolutely. So we're pushing another stack frame on top of copy, array, and manipulate for instructions. All right, super. Now, we are inside of this local execution context. What do we got to do first?
We have to clear our argument.
Uh-huh, absolutely. So what is our parameter?
Our parameter is input.
Absolutely. And what's our argument?
Our argument is 1.
Absolutely. Cool, cool, cool. And then what do we do?
So now that we're inside that body,
Mm-hmm.
we're at the point where it just wants us to return
Uh-huh.
input multiplied by 2
Super duper. All right, and where are we returning that to?
to the second highest call. So we're returning to the stack frame like underneath it.
Absolutely. So we're going to return it to here so we can get rid of this, right? And essentially at this point, what's going to happen is instructions passing in 1 is going to evaluate to 2. Cool. So we pop that off the call stack. What do we got to do with this?
We have the garbage collect.
Absolutely. Garbage collect this. And now we can see, since we popped instructions off the call stack, we're back in this copy and array and manipulate execution context. So what do we do here?
Right. So now we have that value.
Mhm.
So we're going to do output dot push.
Mhm.
We're going to push that 2 into that array.
Perfect. Okay. And then what do we do?
So now we're at in. So we're going to just increment that I.
Absolutely. Cool, cool, cool. All right. How are we feeling at this point? Thumbs? Keep going? Green light? Cool, cool, cool. Okay, super, super duper. Dennis, do you want to try? Do you want to take over?
Yeah.
Yeah?
It's just, I feel like I know what's going on, but explaining it and communicating it is the hard part for me.
Yeah. No, that's totally okay. And like that's why people come here. That's why you come here to, learn how to communicate and practice those skills. So, don't be afraid to make mistakes. It's totally okay. All right. Cool. What do we do next? So we incremented I. Uh-huh.
To 1,
Uh-huh.
checking the condition to see if it is less than 3.
Super duper. Absolutely. Does it meet this condition?
Yes, it does.
Absolutely. All right. So what do we do?
So we're pushing
Mm-hmm.
into we're pushing this into the output.
Mm-hmm. And what exactly, and what are we passing into the push method?
Sorry, yeah, we're pushing
No
the
worries.
instruction. Which is multiplied by 2.
Cool. So we're invoking instructions. And what are we passing into instructions?
The array with the index
Mhm.
of 2.
Of-
1, I'm sorry.
Yeah, absolutely. And what is this array at the index of 1?
2.
Absolutely. Cool, cool, cool. So we invoked this function. What do we got to do?
So we have to create a new local execution.
Absolutely. Perfect. Oh, we're running out of room. Okay, that's fine. We have a local memory. And what else do we have to do here?
We're pushing this into the stack frame into the call stack.
Absolutely, 100%. So we're pushing the stack frame with instructions onto the call stack. All right, now we're inside of this execution context. What's the first thing that we got to do?
We are multiplying the
Okay. But before we do that, we got to pair.
We're pairing the arguments.
Cool. And what is the parameter?
It is array index 1.
The parameter.
Oh, the input?
Yeah, absolutely. And what's the argument?
It says array index 1, which is equal to 2.
Absolutely. Cool. All right, and then what do we do?
Now we are multiplying that by 2.
Uh-huh. And what do we do with it?
We are storing the results into outputs, which
Cool.
is equal to 4.
Cool. So we're returning this. Up here, we'll see that instructions passing in 2 evaluates to 4, and then we can push 4 into the output array. Fantastic. Okay, cool. Now, what do we do right here? So we're done with all the code in here.
It is garbage collect, eligible for garbage collect.
Perfect, absolutely. So we're going to garbage collect this. And what about over here?
You are popping the instructions function for the call to the array.
Absolutely. Cool. And we could see that copy array and manipulate is now at the top of the stack. So that is where we return to. All right. So now what do we do?
We are now checking the condition. Oh, so we're incrementing I to 2.
Perfect. Absolutely.
Checking the condition.
Okay.
2 is less than 3. And it is.
Super duper. I'm going to make this just a little bit bigger for us. So we're running out of room. Okay. Cool. So we've met our condition. Now what do we do?
We're pushing the inputs, which is instruction.
Mhm.
So multiply by 2. With the inputs of array index 2.
Which is
3.
absolutely. Yeah. So you could say, what you could say is we're pushing the evaluated result of invoking instructions passing in array at the index of 2, which is 3. I know that that's a mouthful, but yeah, you could say that. Okay, cool. So we've invoked instructions passing in 3. What do we got to do?
We're creating a new local execution.
Absolutely. So still didn't give myself enough room. I'm sorry that this is so small. Yes, we'll have a local memory. All right, and what else do we need to do?
We gotta push this onto our call stack.
Absolutely. So we're pushing instructions once again onto our call stack. And then what else do we have to do over here?
We're putting in the value of the array index 2, which is equal to 3.
Okay, and what's that going to be stored under?
The local memory.
But what is the label?
Input.
Yeah, absolutely. So we've got our parameter input with the value of 3. Okay, what do we do next?
We're multiplying the input 3 times 2.
Absolutely. And then what are we doing with 3 times 2?
We're returning that value and pushing it and storing it into output.
Absolutely. So we got 6. We're storing that output. Cool. All right, so we're done with the code in here. So what do we do with this?
We garbage collect.
Absolutely. We garbage collect that. All right, what else do we got to do?
So now we're checking the condition.
Bef-
We're incrementing I.
Before we do that,
We're popping.
absolutely.
Right.
Absolutely. Now we're back in the execution context of copy array and manipulate. So now what do we do?
We increment I.
Awesome. And what do we do next?
We're checking the condition
Uh-huh.
to see if 3 is less than 3.
And is it?
It is not.
Absolutely. So what do we do then?
We are now garbage disposing the local memory or the local X.
Before we do that, we've got one more line of code.
We're returning the output
Absolutely.
to the global memory.
Absolutely. And where are we storing that?
Global memory
Under what label?
result.
Absolutely. Cool, cool. All right, then what do we do?
Now we can garbage collect.
Awesome. And one more thing.
We can pop the cam function
Yes,
from the call.
yes, copy array and manipulate.
I'm just gonna call it cam.
That's, it's totally fine. That's okay. All right, super duper, awesome. Cool, cool, cool. And that is callbacks and higher order functions. Yay, good job, everybody. Let's talk about how is this possible? Like I said at the beginning of this workshop, callbacks and higher order functions is not something that happens in other programming language. The idea of passing a function definition into another function in another programming language is just not something that is possible. So why is it that we are allowed to do this in JavaScript? It is because functions in JavaScript are actually just objects. They're just regular JavaScript objects, which means we can pass them around our code base the way we would pass around any other variable like an object. We can assign them to variables. Like we saw, we assigned this function definition that was originally stored under the label multiply by 2 under the label of instructions. We could pass these function definitions into other functions. We can return function definitions from functions, and this is all because functions in JavaScript are objects. Now, I'm not going to get into all of that. We have another workshop just on that concept. So if you're curious about this, definitely attend the Classes and Prototypes workshop, and they'll talk all about this. But this is just why this is possible, because functions are just objects, which is pretty cool for us. Now, I have a question for all of you. Which is the higher order function, and which is our callback function, and how did you know? Now, if you know the answer to this, you can raise your hand. And if you get it wrong, then we're going to start the workshop all over from the beginning. So, are you ready for all that weight to be on your shoulders? Yeah. All right. Which one is which?
Well, it's funny because I was gonna actually go over what this is, but I know.
Okay.
I hope so. So, which is our higher order function?
Uh-huh.
Higher order function is the function copy array and manipulate function.
And why do you think that is?
Because we're able to pass another function into that
Okay.
function.
So which one is the callback?
Multiply by 2.
And why is that?
Because we're passing its definition into a higher order function,
Mhm.
and then we're calling it inside of a higher order function.
Yes, absolutely, 100%. Yes, perfect, great explanations, yay. We don't have to go through it all over again, yes. Yeah, absolutely. So the higher order function is just a function that takes in another function as an argument. That's all a higher order function is. It has this parameter that is meant to be a placeholder for a function definition. And then our callback function is just a function that we pass into another function. Now, multiply by 2, this is just a regular function. There's nothing fancy about it. If I wanted to just invoke multiply by 2, like underneath where I'm declaring result, to multiply some number by 2, I absolutely could do that. I don't have to specify like, hey, this is a callback function. I can just declare a function and use it as a callback if I want to. It just becomes a callback when we pass it into the function invocation of copy array and manipulate. Cool. Can I get thumbs on that, the higher order function versus callback? Cool, cool, cool. Just remember, higher order function is the function that takes in another function. Callback is the function you pass to another function. You can do a lot of things with this concept. Like we said before, this makes our code more declarative, more readable. Basically, it makes it less repetitive. It makes our code kind of less bloated because we can write less code by using callbacks and higher order functions. These functions map, filter, and reduce. If you've used map before, that's basically what we created here. With this copy array and manipulate function. This is essentially the map method on an array. When you call the map method, you call it on an array, and the map method will copy every element in that array and it will perform whatever functionality you tell it to when you pass that into the map method. So we essentially just created that right here. Furthermore, like I said, this is definitely going to be on the Codesmith technical interview if you're interested in getting into the program. So keep practicing at this. It is a really important foundational concept. Like I said, a lot of the technologies, a lot of the libraries, frameworks that we teach in the program do use callbacks and higher order functions. So this will make it a little easier to understand those more complex technologies. Similarly, when you get into asynchronous JavaScript, has anyone gotten to the async unit in CSX or started diving into that? Yeah, Patrick, you have. Sharif, you have. Yeah, Taylor. Cool. Async is tough. It's a really challenging concept. It took me a while to really wrap my head around asynchronous JavaScript. But if you understand callbacks and higher order functions, it will make it just a little bit easier to understand it, because you'll need to know callbacks in order to understand asynchronous JavaScript. So keep up the practice. That's it. That's all that I have for y'all. Thank you all for hanging out. Thanks all for attending, for participating. It was super cool.